Welcome back to part 4 of our series on solving systems of equations. So we made it this far, we have one more to go. Today's topic, again, solving system of equations, is can we solve equations by the method known as elimination? Can we use elimination? Elimination. The goal here is almost to cancel something out, to eliminate a problem, to eliminate a value. And in doing so, hopefully, we can solve for our x and then our y, respectively, or vice versa. So here we go. We have an equation on our screen. Negative 7x plus 4y equals 24, and 4x minus 4y equals 0. Now, unlike a problem like this, I wouldn't really look to using graphing. Graphing wouldn't work. We could do substitution. We could try to get a variable by itself. But a problem like this, a setting like this, really sets itself up for elimination. And here's why. If we wanted to solve this problem using elimination, we sort of want to add the equations together and we want a variable to cancel out. So imagine, if you would, in this problem, if we would just add the two equations together. What is negative 7x plus 4? Negative 3x. What is positive 4y plus negative 4y? That'd be 0. And then 24 plus 0 is 24. Notice when we combine these two equations together, what happened to that y value? It got eliminated. And that's exactly what we're looking for when we're going to be using this elimination method. Can I add the two equations together to get a variable to cancel out? So, continuing this problem, again, I add them together, the variable canceled out. I can now solve this equation for x. I can solve this equation for x, divide both sides by negative 3. I get the value of x equals negative 8. Are we done? Not quite. With all our problems with systems, we need to get that y value. So we're going to plug that negative 8 back into one of our equations. Does it matter which one? No. I'm going to pick let's go with the bottom one. Sure, why not? So we'll say 4 times negative 8 minus 4 times y equals 0. It's negative 32 equals negative 32 minus 4y equals 0. Subtracting it over, negative 4y equals 32. Divide by that negative 4, y equals negative 8. So my solution is the point negative 8, negative 8. So if we were to graph those, that would be the point they would cross. And that's what we're going to be doing for elimination. Can we add those two equations together in such a way that a variable gets eliminated? Now, this was a nice problem. Things worked out nicely for us. They're not always going to be this clean. So let's look at a couple more examples to see what would happen. Here, in our second example, if we were to add down, would one of our variables get eliminated? Well, negative 7x minus x is 6x. 2y plus 2y is 4y equals 2. None of my variables got eliminated. So that really hasn't helped me quite yet. So what we want to look to do is, can we manipulate one of our variables? And the way we're going to do this is through multiplication. So can I multiply one or even both of my equations by some value such that then they would cancel out? Well, maybe you noticed they both had that positive 2y. They both had that positive 2y. So if we wanted to, we can multiply one of those equations by a negative 1. And then when we added them together, something would cancel out. So which equation do you want to multiply by negative 1? Again, it doesn't matter. How about we do let's do the top equation. Let's multiply everything in this top equation by negative 1. If I multiply everything in the top equation by negative 1, I'll write that answer underneath. I'll rewrite it for us. This turns into negative 7x minus 2y equals positive 19. So I took that first equation, I multiplied every single term by negative 1, and I wrote it underneath. So that first equation got written underneath. So now, after multiplying that first equation by negative 1, what happens when I add my equations together? Let's see it now. negative x plus negative 7x, negative 8x, positive 2y plus the negative 2y, those are going to go away now, and 21 plus 19, 40. Do we have an equation that's now only in one variable? We do. We have negative 8 equals 40. We've eliminated the y. Our elimination method works for this problem. And if we finish solving for x, we get the value of x to be negative 5. Again, we need to solve for y. It doesn't matter which equation we plug into, the original, one of the original, or even that modified one. Any of these first three equations we could have plugged into, or we can plug into, excuse me, and we'll get the right answer. I'll go with the middle one just because, why not? So if I plug in negative 5 into that equation, I get a negative of negative 5 plus 2y equals 21, or that is 5 plus 2y equals 21. Subtract the 5 over, I get 2y equals 16. Divide by 2, I get y equals 8. So I get a final answer, a negative 5, 8. That would be the point where those two lines would intersect. So for the second equation, we had to manipulate one of our equations, and that's fine. If you need to multiply an equation by some value, positive, a negative, a constant, if you need to multiply, that's okay. And that's what we did here. We multiplied by negative 1, so those y's would cancel out. So let's try one more problem, see if we can manipulate our equation. Again, we have 6x minus 12y equals 24, and negative x minus 6y equals 4. If you want to pause the video and try this problem on your own, please do. Otherwise, if we are going to solve this, we can see very quickly if we just add them together, nothing would cancel out. So we need to multiply one of our equations, or possibly both of our equations, by some value so that they cancel out, so that they're opposites. So what I see when I'm doing this problem, I see two options. Do you want to cancel out the x or the y? And there is no right or wrong answer which way you do this. Because we've canceled out the y's in the previous problems, let's try to cancel out the x's in this problem. So we have a 6 here and a negative 1 down here. 6 on the top, negative 1 on the bottom. What I'm really looking for is that for the two equations, they're opposites of each other. So if the first equation is 6, can I make that second equation a negative 6 somehow? Well, I can. I can make that second equation a negative 6x if I multiply this whole equation by 6. So if I do that, if I multiply that whole second equation by 6, I would still have that first equation as what it is. But if I multiply that whole second equation by 6, that second equation will turn out to be negative 6x minus 36y equals, if I could do my numbers right, that'd be helpful, positive 24. Now we can see right there our x terms. One's a positive, one's a negative. So now when I add my two equations together, when I combine them, 6x plus negative 6x, those two terms get eliminated. Minus 48y equals 48. If I solve for y, I divide by that negative 48. I get the value of y to be negative 1. Again, we're not done. We need to solve for that value of x as well. It doesn't matter which equation we plug into. No, I will go ahead and use that second equation there. So we'll say, we'll do it right here on the side. Negative x minus 6 times negative 1 equals 4. Negative x plus 6 equals 4. Negative x equals, if I subtract that 6 over, minus 2. X equals 2. So my solution is the point, the x, y. There's the solution to my equation. Again, the elimination method, we're trying to get it so that one of the variables, either the x or the y, those coefficients or the numbers in front of them are opposites so they get canceled out. You've seen the elimination method, you've seen the substitution method, you've seen the graphing method. Most people have a preference which ones they like. However, for any problem you encounter, you can use any of the methods. Just no matter what you're comfortable with. The reason we show you all three methods is because they're different tools to be used. Some are more useful in situations. So I encourage you to try them, figure out which ones you like. Let me know if you have any questions. Otherwise, you have a wonderful day. Take care and be well.